Now that you've learned many of the different concepts of congruent triangles, we're going to apply them more to real-world situations. But before we do that, let's just kind of sum up what we already know. We've already learned the side, side, side. Oops. Side, angle, side. Hypotenuse, leg. Angle, side, angle. As well as the angle, angle, side congruence postulates. These are the only 5 postulates that you can use when trying to decide that triangles are congruent. Don't try to make some up on your own. A lot of people try to say, oh, well, we have 3 angles that are congruent, so let's say these triangles are congruent. But you just can't do that. These are the only 5 that you can use, and stay away from that common one that seems to show up all the time. It's not a very nice word, and we'll try to stay away from that one. So again, these are the only 5 we can use. And remember, 2 triangles are congruent if and only if. So this goes both ways. Their corresponding parts are congruent. That would also imply that, well, if you have the corresponding parts congruent, then these 2 triangles are congruent. So that if and only if is a two-way implication. And we call this the corresponding parts of congruent triangles are congruent. And we're going to use this a lot. So instead of writing that really lengthy sentence, we're just going to write Cpctc. Just remember that means that all the parts of a triangle are congruent. In this section, you're going to be asked to explain how you can use given information to prove a statement is true. So this isn't necessarily a formal proof, but it's more of a thought process behind it. You have to first mark the given information. As I've already taught you in the last lesson, we're given that angle 1 is congruent to angle 2. So what you can do is mark those congruencies. We're also given that AB, side AB, is congruent to DE. And we're trying to prove that DC is congruent to AC. Our second step is to add any deduced information, so things that we can pull up from facts or theorems and postulates that we already know. If we focus on these angles first, angle ABC as well as angle DEC are both supplementary to the given congruent angles. So what we can say from that is that angle ABC and angle DEC are congruent. And because they're supplementary to congruent angles, so we can just say that those 2 angles are congruent, and I've written it out all here. Next up, we can also say that angle ACB is congruent to angle DCE. And that's because these 2 angles are vertical angles. They're across from intersecting lines. So I am going to denote that on the picture with a double angle mark. Those 2 angles are congruent, and then I'll write it down. So now we're left with 2 angle pairs and a side that are congruent, and 2 angle pairs and a side, they're congruent. So what we can use is angle, angle, side to give us that triangle ABC is now congruent to triangle DEC. Now, this is all information that you've seen in the past, this whole method to showing how these things are congruent. But what the question asked for here was to prove that these 2 segments or 2 sides of the triangles were congruent. We haven't exactly shown that yet, though since the triangles are congruent, we know by this new added thing, the corresponding parts of congruent triangles are congruent, that, well, yeah, these 2 parts are going to be congruent. So the only added step in this section is to say by the Cpctc, we can say our conclusion, what we wanted to prove, that side DC is congruent to side AC. Let's take this proof step by step. We'll start by writing down the given. We're given that AB is parallel to CD, so I'll put my arrows to indicate parallel. And we're also given that BC is parallel to DA. In the end, we want to come up with endgame of proof, last step, that AB is congruent to CD. So just have that endgame in mind. AB, this segment here, is congruent to the segment over here. Now we have to come up with some way to do this. And whenever I see parallel lines, I automatically go to alternating interior angles, alternating exterior angles, corresponding angles, all those theorems we learned in the last chapter of the book. So I have my two parallel lines here, and I have a transversal which is represented by BD. So the angle ABD as well as the angle CDB are on alternating sides of the transversal, and they are inside or interior to the parallel lines. So we can say that they are congruent, and I'll put my tick marks on the diagram, by the alternate interior angles are congruence theorem. We can do the same for the other angles, angle ADB here, as well as angle CBD here. They are congruent by the same means. So we might as well just keep them all in the same step and add those angles in. So now we have two congruent angles of the two triangles, and we need a side somehow. So this side BD is shared by both of them, so by the reflexive property we have that it's congruent to itself. So what we've come up with now is two angles and a side interior to the angles. So using the angle side angle congruence postulate, we can say that these triangles are congruent. Make sure though that you are lining up the correct vertices. So A matches up with C, B matches up with B, D matches up with D. So we have that triangle ABD is congruent to triangle CDB. Now notice we're not at what we wanted to prove yet. Now we kind of know ahead of time that if the triangles are congruent, yeah, the sides are going to be congruent. But we have to take that one extra step using what we've learned in this chapter, which is that side AB is congruent to side CD by Cpctc. Corresponding parts of congruent triangles are congruent. So we just write down Cpctc and we're done. Here's a rather simple problem. Let's start by writing down the givens. So I write down A is the midpoint of line segment MT and SR. In step 2, midpoint should tell you right away that, well, hey, a midpoint splits a segment in two. So it's going to split this segment into two and this segment into two, leaving us with our congruent sides. So we can say by the definition of a midpoint that MA is congruent to AT, as well as SA is congruent to AR. So now at this point we have two sides, and we have to find 1/3 quantity, something about these triangles. So we could look for another side, but in this case there's nothing really that will relate those two sides. So what I recognize is whenever we have these intersecting lines like this, I see vertical angles, and vertical angles are congruent. So we know that these two angles here are going to be congruent. So we can state that angle MAS is congruent to angle, again keep in mind that the orientation needs to be the same, so MAS is TAR in this case, TAR, and that's by the vertical angles. So now what we have is a side, an angle, and a side, an angle, and a side. We're done. Step 4, we can say that these triangles are congruent, so triangle MAS is congruent to triangle, again keep those vertices lined up, TAR, by side, angle, side. But we do have one less step. We had to prove that these two line segments, SM and TR, were congruent. So the additional thing we learned here is using the Cpctc, corresponding parts of congruent triangles are congruent, we can say that SM is congruent to RT. And that's our proof. I could keep on showing you examples, but at this point, I really would like you just to focus on the couple examples I gave you, and we're going to apply them in class the next time I see you, and you will be expected to kind of go through the same thought process and breaking it up into things that you already know to build these proofs.